Chapter 1, Circuit Variables. In this lecture, we will discuss the concepts of charge, current, and voltage, their relationships to one another, and their associated mathematical equations. We will then perform some example problems demonstrating the concepts learned. We are looking at objective number 2, which is to know and be able to use the definitions of voltage and current. This is a circuit analysis class. What is an electric circuit? An electric circuit is a collection of electrical elements which are interconnected in a specific way. Elements that we will be studying include power sources, such as batteries and generators, and passive elements, such as resistors, inductors, and capacitors. In this circuit, we have several circuit elements. We have two sources, a current source on the left and a voltage source on the right. We also have three resistors, an inductor, and a capacitor. Most circuits have at least one closed path, otherwise it would not be very useful. For a conductor to have a steady current, it must be part of a path that forms a closed loop in order to complete the circuit. This circuit has at least two paths. Make note that because of the switches, it looks like more. We will be analyzing circuits like this one in Chapter 8. Let's go a little simpler. Let's start with an ideal basic circuit element. Basic circuit elements form the building blocks for constructing circuit models. The ideal basic circuit element has three attributes. 1, it has only two terminals, which are points of connection to other circuit components. Note that transistors and op-amps have more than two terminals. We will be learning about op-amps in Chapter 5, but transistors are beyond the scope of this class. 2, an ideal basic circuit element is described mathematically in terms of current and/or voltage. And 3, it cannot be subdivided into other elements. Using the word ideal implies that a basic circuit element does not exist as a real physical component. We use ideal elements to model actual devices and systems. So let's review. A circuit model is a mathematical representation of an electrical system. In modeling an electrical system, we use ideal circuit elements, which are interconnected in at least one closed loop. Circuit analysis is based on the variables of voltage and current. In each chapter, we will be looking at the quantities of current, voltage, and power associated with circuit elements. Let's begin with the concept of charge. The concept of electric charge is the basis for describing all electrical phenomena. We are familiar with gravitational forces of attraction between bodies, which are responsible for holding us on the earth and causing an apple to fall to the ground. There are also forces which are electrical in nature. These forces attract outside of the proportion to masses, and we know that these forces are caused by the presence of electrical charges. An important characteristic of electric charge is that it is bipolar, meaning that electrical effects are described in terms of positive charges and negative charges. We explain the existence of forces of both attraction, which is the force between unlike charges, and repulsion, which is the force between like charges, through the existence of the two types of charge. Matter is made up of atoms composed of fundamental particles. The most important of these particles are 1. Protons, which have a positive charge, 2. Neutrons, which are neutral or with no charge. Both protons and neutrons are found in the nucleus of atoms. And lastly, electrons, which have a negative charge and move in orbit about the nucleus. Particles may become positively charged by losing electrons to other particles, or become negatively charged by gaining electrons from other particles. Charge is represented by the letter Q and has the unit of coulomb. Let's define the coulomb. A coulomb is the charge of about 6.24 times 10 to the 18 electrons. Stated another way, the charge of an electron is a negative one of 1.6021 times 10 to the minus 19 coulombs. So we can say an electron has a charge equal to minus 1.6021 times 10 to the minus 19 coulombs per electron. Protons have a positive charge. So a proton would be plus 1.6021 times 10 to the minus 19 coulombs per proton. These are mind-boggling numbers, but their sizes enable us to use more manageable numbers in circuit theory to follow. The motion of charge creates an electric fluid or a current. We say current is the flow of charge or the rate of charge flow and is the measure of the amount of charge or the number of charged particles that pass a point per unit time. In circuit theory, current flow is generally thought of as the movement of positive charges. This convention comes from Benjamin Franklin, who guessed that electricity traveled from positive to negative. We now know that in metal conductors, the current is the movement of electrons that have been pulled loose from the orbits of the atoms of the metal. However, we maintain this convention for current flow. The SI unit of electric current is named in honor of the French scientist André-Marie Ampère. We label current with a capital I or a lowercase I. Although current is made up of discrete moving electrons, we do not need to consider them individually because of the enormous number of them. Rather, we can think of electrons and their corresponding charge as one smoothly glowing entity, so I is a continuous variable. So, the primary purpose of an electric circuit is to move charges, and this movement of charges is what we call electric current. Moving or transferring charges along specified paths must include some device that provides a force. Charges in a conductor have a lot of random motion. If we want charge movement to be concerted, we must apply an external force. The charges then move in the direction of the force and work is done. Voltage is defined as the work done in moving a unit of charge through a circuit element from one terminal to the other and is mathematically represented by dW over dQ. The SI unit of voltage is the volt, named in honor of the Italian physicist Alessandro Giuseppe Antonio Anastasio Volta. So, 1 volt is equal to 1 joule per coulomb. A battery with a voltage of 1.5 volts does 1.5 joule of work on every coulomb of charge that passes through it. Batteries, electric generators, solar cells, thermocouples, and fuel cells are all sources of voltage. A common misconception is that voltage sources provide charges to the circuit. This is not the case. Rather, charges that make up current are already present in the conducting wires and circuit elements. Voltage and current may be DC or direct current. This is a term used for both current and voltage. They may be variable, pulsating, or AC, which is alternating current. Again, this is a term used for both current and voltage. This class will focus first on DC sources, then AC, starting in Chapter 9. We can relate current and charge by integrating the equation for current to arrive at an expression for charge accumulation. Or we can differentiate charge with respect to time to arrive at an expression for current. Let's use these equations to solve some example problems. Click on the link below to view the video for this problem. Click on the link below to view the video for this problem. Click on the link below to view the video for this problem. Let's review what we have learned. We introduced the following concepts: the concepts of charge, current, and voltage. We defined equations for current, voltage, and charge, and we solved some example problems which related the concepts. That concludes this lecture.